Okay. Hi, good evening, everyone, and thanks for joining this revision session number 2 for the quiz 1 of the reinforcement learning course of the BS program. Okay. So already we have done revision for quiz 1, but I have kept this again to clarify or to discuss any doubts about any PYQ or any GA question. So we can take that up one by one. So with that, I will start. I will encourage all of you to please pipe up and share your, doubts and queries. We can discuss that. Yeah. Okay. Week 3 and week 4 theory once. Okay. Okay. Thank you, Ravina. So what I recollect, week 3 and week 3 started with the value functions, then value action state functions, then the value star function, then value state action star. After that, we went to policy iteration, then value iteration. After that, we saw that what is dynamic programming. It is a with bootstrap, and of only with sampling, that is a Monte Carlo. And when we come to TD, that is a temporal difference. Temporal difference has got both. It has got bootstrapping also, and it has got uh, sampling also. So don't worry, I will just open week 3 and week 4 and we can go through that. Okay, just give me a minute. Yeah, okay. So week 3 and week 4 we'll go. So other than that, any question or any clarification in week 1 or week 2? Anybody? So before we start week 3 and week 4? Okay, so I assume there is no doubt, nobody is answering. Okay, so we will start quickly about week 3 and week 4. Okay, so just let's go. So this is the value function. Value function I will just cover here. V pi of s, V pi of s. There is a
Sir, your screen is not visible.
okay, okay. I think I have not shared my screen. I will share my screen and then it will come up. Is it visible now? Okay, very nice. Okay, so we come to first value function. So value function basically, I will just give you an example here only. I will add a page, a fresh page, plain tools or journal, new page, a new page after. Okay. So how does a value function looks like that if there is an optimal policy, so if there is a grid and we have got states. So again, I will take the same example which we had discussed earlier. So we have got these 9 states, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for example, this is your terminal state. So the value function of 3 will always be equal to 0. And now we have to find the value function as per pi. So this is of any state. So this pi can be any policy. So if it is a stochastic policy, that in one, for example, in state one, and there are actions north, south, west, east, and I have to calculate now value function of S. And policy says that in one, I can move north, south, east, west with equal probability. Equal probability. So this is the, and in fact, okay, I can say in all states. And reward is, this is the policy, and reward is -1 for every step. So this is your MDP. So how the MDP looks like? MDP is equal to S, action, policy, reward. So state has come, action I have given, this is the policy, and this is the reward. So all four things are there. So now when I have got something like this, so I have to calculate the value function for all the states. So how I will, first I will write the formula, and before, so V pi of S is equal to summation of, I think somebody wants to enter, I have to allow entry. Yeah. Was there any message here? Am I audible?
Yes, sir. You are audible.
Yeah. So I will just cover this V pi policy. So this is the value function of a state as per some policy. So this is the policy. So in case of a stochastic means I have got equal probabilities of all four actions. Then I have to cover the entire policy action over in that state. So I will cover for north also, south also, east also, west also. Thereafter, I will cover all the next state's probability of S prime over S over A into reward of S A S prime plus V policy in S prime. So what is the value function of the next state? So this is very, very important to understand.
So gamma is not used.
Yeah, sorry, gamma, gamma.
So discount is also there now.
What? So
Discount gamma.
see, in this case, I did not write gamma because here terminal state is well defined, and in this case, gamma is equal to 1. Oh, otherwise, okay, gamma is there. Okay. So you recollect a week 2 lecture, gamma is equal to 1 for the when there is a terminal state. But we can write V pi of S prime. Is this okay?
Yes, sir.
Okay. Now, from here, there are very important things. So we will do one calculation here, for example. I will just for this. So if I do calculation of V pi of 1, so I will consider all actions. So all actions probability is how much? 0.25. So there are four actions, 0.25, 0.25, 0.25. Okay. So first I take S prime. For example, I am moving north. So when I move north, what will be my S prime? I will come back again to 1 only. And this probability of S prime over S over A is 1 here. That in case I move north, I will come to S prime only, 1 only. What is the reward? Is -1 plus gamma. For example, if I take gamma is equal to 1, here it will come gamma is equal to 1, for example. So 1 into V pi of 1, because your S prime is also 1. This is clear? Now plus, now I take a step towards west. So when I take west, again I will get the same 1 into -1 plus 1 into V pi of 1 plus, now I cover east. So this will become now 1 into -1 plus 1 into V pi of 2 plus Now you come to south. 1 into minus 1 plus 1 into v pi of 4. So this how we get all these equations. So this is for a stochastic policy. Okay. Now if
So I didn't get why the probability is one. Is it deterministic?
no
Why
no
we think of one in all the cases?
see, this is a case when I'm going north, and what is the probability of that is 0.25.
1.25. Yes, sir.
When I go north, so what is the probability that I will come to 1? It is 1.
Full,
I can
yes, sir.
I cannot go anywhere na, if I'm going north.
But then, sir, on east also, sir, you have taken one. We
So
can go
so
south also.
just hold on. Just hold on. So see, this first case is for north. Okay.
Yes, sir.
Second is for west. If I go west, where I will end up? If I
Same.
go same.
Yes, sir.
If I go east, where I will end up? I will end up here only, na?
Okay. But, sir, yes, sir, got it, sir.
Okay. If I go south, I will end up here only, na? I cannot go anywhere else.
Yes, sir.
Yeah, clear? Okay. Now what happens for the Bellman equation? Now when you have done this, so you remember, so here you have got V pi 1, V pi 2, V pi 4. Similarly, you will do for V pi 2, you will do for V pi 4, V pi 5, V pi 7, all that. Now all of these equations are linear equations. Linear equations which can be solved. And these are equations are known as Bellman equations. Okay. And when you do update, once you solve that, so you will get values. So that is known as Bellman update. Bellman's update. Okay. Shall I solve a very, very simple example for this?
No, sir, it's easy, sir. We can solve the equations.
Oh,
Like here also, we can shift the v pi of 1 to the left side
yes,
and we can
yes,
solve it, put it to
yes,
the other equation.
yes.
Yes.
Now there are some important considerations. Okay. So first take important considerations. Number one, for a deterministic policy means that pi o a over s is fixed. It is not stochastic. Okay, it means that north over 1 or east over 1 is fixed. East over 1 is fixed. Okay, deterministic. Then your value of pi over s, so your first term which is there, pi over a over s, is removed, and only you are left with s prime over p of s prime, s over a into r s a s prime plus gamma v prime s prime, v policy s prime. Is this okay? So this is not there for a deterministic policy.
Sir, I have a doubt here also. So,
Yeah,
sir, east is fixed, like so it is deterministic, so it will take pi as 1.
yeah.
So when we will write this equation of value function, so if we consider all the actions, so north, west, and south, will it
No,
be 0?
no. Remember, now there is no north action. There is no north. There is no south.
No,
There
that's
is
what
no
she's saying.
west.
It'll be zero. Yes, it'll be zero.
Yes,
For
yes.
every
I love
for
you,
every
Ibrahim.
state, sorry, for every state, there's only one action. So one
Yeah.
action will have probability 1, all others will have probability 0.
Yes. Okay. But in
Okay.
case okay, like in PYQs, they have asked a question like this: that for a deterministic, so for deterministic, this first part which is there, it is removed. Is that okay, Ravina?
Yes, sir.
Okay.
Actually, if you remember the formula for non-deterministic, then it will solve the deterministic also.
Yes. Yes. Okay. Now we come to the next important point. The second important point is value is value action state function. State function. So that is, if I'm not wrong, that is Q over S over A. It means that I'm in some state, I take some action in that state. So my first action which is there, so this is Q pi. The first action which I'm taking, it is not as per this policy, that I'm taking as per the S prime over SA. So first action I'm taking this action, and thereafter what I'm getting reward SA S dash. But after first action, I will follow V pi or in S prime. Okay. So for example, I will just say that I will take the same example. I have got 4 grid, 1, 2, 3, 4. This is my terminal. And policy says that I can move north also, south also, east also, west also with 0.25 probability. But when I'm considering, for example, Q pi S, and I'm considering action only north, then I will say that first action I will take north, and then after I will take action as per the policy. Is this understood? So what will happen in this case, for example, if I go north, I again come back here, and after that, now I will consider all the 4 things, that I can go north, south, east, west also, and I follow the policy. So whatever value I will get, that will be the Q pi of S over and north. Now, if you try to correlate this now with, and why, remember here, this Q pi, here it is V pi, because after the first action, I am following the policy. I will take the actions as per the policy. So this is the important. Now, if you consider now V pi of S, you can write down as pi S over A, and you can write down this as Q pi S over A, because the second part of V pi S is same as Q pi S. So this is one important thing. Any discussion on this question or this concept?
Actually, there are these 3-4 equations that people should memorize them.
Yeah. And if we understand also this conceptually, it is very, very easy.
Yeah.
So we will go sequentially now. Ravina, this is okay? This is clear to you?
Yes, sir.
Yeah. So remember, in the state action value function, which is Q pi SA, the first action I am taking the action which is designated action, but after that I will take the actions as per the policy. That is the main concept.
So, sir, after this designated action, like not written here, after that would we be adding the pi also or not?
No, there is no pi in the Q pi, but here when I will calculate this action, so I will consider all S primes. So S prime can be this also, it can be this also, it can be this also, coming back and coming back. So I'll consider all 4 actions. If it is a stochastic.
Okay, sir.
Okay.
So, sir, then north will be added twice.
So I have taken first step. I took first step as per this. I took first step and came back here again. Okay.
Yes, sir.
So this is the first step here. I got this reward, and this is the summation. Okay. After this again, I will follow the V pi and will take all these 4 actions because it is a stochastic policy. Okay.
See, from your current state, you once evaluate what will happen if I'm taking action A. Action A is fixed. Okay, it is fixed in the beginning that action A is the one. But for the next step, any of the actions as per policy in that state will be feasible. Okay, so when we are writing here V pi S prime, the action over there is actually different from the first action that written over here. There you have got A prime as the action. So in your first step, one of the actions is fixed, but in the next step, any of those allowed actions could be happening. That's the only thing you need to take care, that these are two different steps.
Yeah. Okay. Now let's go to second another thing. So we will keep on solving some questions also. So let's go through the slides also. So this we have covered. Okay. This we have opened. Bellman equation we have seen. We an example optimal value functions. Okay. Now this is a very
Lalitji,
Haji.
is there any distribution like from which week most of the content or questions are likely to happen?
Lovely ji, only all five PYQs which are there.
Yeah.
I think week 3 and week 4, I think 60 to 65% questions
Okay.
are from week 3 and week 4.
Okay.
Yeah.
And these are all those. I believe the equation kind of questions are easy, and
Yes.
some of them maybe those grid and those kind of questions where they've given example and you have to make mistakes in those examples.
Yeah.
Yeah. Typically, okay. Good.
Yeah.
Yeah. Continue.
Yeah. Thank you. So now there is another concept, okay, which is now the optimal value function. Optimal value function or the optimal policy. Optimal policy. Now remember, one problem can have various optimal policies. For example, again, we take this case. So this is a terminal thing. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So this we have solved during our last revision session. And we had seen that in this case, if we have got, for example, north, south, east, west, this is the action. State we has got 1, 2, 3 up to 9. Then we have got gamma is equal to 1. And we had seen that, for example, if I start from 7, I can go like this also. I will get the same reward. I can go like this also. I will get the same reward. I can go like this also. I will get the same reward. I can go like this also. I'll get the same reward. I can go this also like the same reward. It means it has got many optimal policies. Many optimal policies. But remember, the value function which will be there, value function and the reward will be same for all optimal policies. This is very, very important. Okay, number one. Number two, an MDP can have many optimal policies, but definitely one at least one deterministic optimal policy.
Why, sir?
So this proof a professor has not given, but I think in the NPTEL lectures he has given, but he has mentioned in the lecture. So remember this. It might come again in some objective kind of question. Okay. If you remember, professor had also covered that for a stochastic MDP, there can be infinite optimal policies also. But it is assured that there will be at least one deterministic policy. Okay, so from the quiz point of view, we just remember this. There is a proof. I have not done that proof. Okay.
Yes, sir.
Okay. So this is the basic crux of what professor had covered in this optimal value functions. Now we will come to V star and Q star because that funda is very, very important. Now, what is V star? So V star of pi over S is the optimal value function that once I have got the optimal policy, now the value function for that will be my V star. And how do I define? I do a max over this, that the maximum value function, the policy which is giving me the maximum value function, that is the V star of S. That is for all states, the policy for all states, if I get the maximum value function, that is my V star S. Very, very important thing is here, this question has been asked in GA also, in some PYQs also. Similarly, the Q star S of A is same if you correlate this. Maximum, the policy which is maximizing this Q by S over A. But here I will write, which has not been covered in the lectures, is Q pi star. That is the policy star S over A, or is argmax A Q pi S over A. So this is the difference between this and this from the quiz point of view. That if you are asked for a policy, best policy, that's the optimal policy, it is argmax over A, whereas Q star is the maximum of pi. Similarly, V star pi is max pi. Now, how to solve these kind of questions? For example, we are asked to find a V star. So remember, there is a question in the PYQ that here is one state 1, here is one state 2, here is one state 3. 3 is the terminal state, and here it is written that if I take some action, I come back to this only with a probability of 0.2, and my reward is 0.1, and I go to terminal 0.8 with a reward of, for example, -1. Similarly, here I come back, if I take this action, -1 over -1, and if I go right, then I have got 0.2 over 1 and 0.8 over, for example, 2. So this is one example from the PYQ. Now, how to solve this question? So we have to, for example, find V star of 1, for example.
Lalit, is it correct?
Yes, it is correct. Okay.
Because in the state 1,
Ah.
you have got 3 actions.
No, there are only 2 actions. So one action is when I move right, and in right,
0.8. Yeah.
and I have got 0.8 and 0.2, and all other functions which are there, I come back here.
Yeah. No, but from 1, you take some action and come back to the same one.
Yeah.
With the probability of 1.
Yes.
So there are 3 actions, that means.
No, there are 2 actions. So I also got confused in this question. And when I saw the V star, so here what is happening in this? What is happening? I'll just say, there is one action. I go right, and I go, for example, these are 3: north, south, east, west. Oh, sorry, west. And this is the west function. So when I take these actions, north, south, east, west, I come back to the same state, and the
Yes.
probability is 1 over -1.
No,
Okay.
why is it probability 1? Is it the probability of taking an action, or is it the probability of reaching to the next state? Which probability are you referring to?
This by probability 1, you will come back here.
Okay, so that is the P, it is not the pi.
It is P. It is a
Okay,
P.
then it is
Okay.
fine.
Yeah. And if I go west, then I've got 2 states that by 0.8, I will go west, okay, and 0.2, I will come back again.
Okay, fine.
Okay. So in this kind of question, I also got, confused in this. So when I have to find V star 1, so I know that V star 1 is nothing, will be my probability of S dash, that is, or I can say,
Actually, there is something missing here.
V
In
star.
the questions,
Yeah.
typically they're showing the states and actions by different nodes.
Yes.
Okay, so 1 is a state and 2 are these states or are these actions?
So these are states. Okay. This
Okay.
1,
Yeah.
2,
So in most of the
3.
GAs, they have got some bubbles for states and some bubbles for actions.
Yes.
So there we are able to distinguish between the pi and the p probability. And in PYQs, are they giving like this?
No.
Or
So this is straight away is from PYQ. Very, very similar.
so they're not using different bubbles for states and actions?
No.
No, sir. They are using the black color for action
In
and
in in
for.
in, in some questions, but in this particular question, they have not used.
Then this is very misleading or I mean,
Uh,
confusion wala hai. This
yeah.
is
So if we say, for example, V star of a K, for example, here V star of 2 we calculate first. So V star of 2 is very, very straight. V star of 2 is equal to 0.2 into minus 1 plus V of V star of 2 plus 0.8 minus 1 plus 0. So this will become minus 0.2 plus V star 0.2 minus 0.8. So V star of 2 will become minus 1 over 0.8. So this we get some value, for example. This will become minus 1.25, minus 1.25. Okay. Now, here in the next V star 1, V star 1, now we have to remember that there are two actions which are there, either north, south, west. This is one action. Second action is east. So I find the maximum value function which is happening for all. For that, I will consider V star 1. So let's consider, for example, for this first function. So for that, V star 1 will become, I take this function, I come minus 1, I get 0.8 into V star of 1. Therefore, V star of 1 will become minus 1 over 0.2, which becomes minus 2.5. And now I can calculate V, sorry, this is not V star, this is V1, action north, south, and west. I consider now V1 east, which will become now 0.8 into 2 plus 0.8 into V2, which is minus 1.25, plus 0.2 into 1 plus V of 1. So I solve this, and if I find that this V1 is greater than this, then only this will become V star of 1. Okay, so this we have to be careful that we have to calculate for both, because if we see the equation, it is maximum of those actions. Okay, so here maximum pi V pi of S. Okay, so this shall I show some PYQs with this concept, Lavlinji?
I have one question. So can you scroll
Yeah,
in the diagram, sir? Sir,
yes,
yes, sir. So like there are two loops here. So if there are like four loops and one is in right direction, total five path. So we have to consider all the possible cases, and then we have to find which is giving us the maximum value that we have to pick.
yes, yes.
Okay, sir.
Okay, so that is, now there is another very important. So I will write down here in the slides only, and before after that we'll just quickly scroll down the PYQs. This one example is there, we have seen. So this was the example of saying that we can have multiple optimal polys, but only one optimal value function. Bellman equations we have seen. This is a very, very important formula. Please remember this. This V star S is equal to Q star SA, maximize the action which is maximizing this. So if you remember, we had done the same thing. We had found Q pi star, and then we did for all actions to find which is the maximum. And that is my V pi star, V star S. This is a linear equation. Now here I will write something, that Bellman equations which we get for V pi of S are linear, but for V star of pi of S is not linear. Why? Because max function which is there, maximum out this is not a linear function. Okay, so we have to just remember this. Okay, optimal state value functions are there.
Choosing, sir, we
Yeah.
are choosing from all the linear functions now, then how it can be non-linear then?
No, see, maximum is not a linear function. Okay. When we do, for example, a1 is equal to b1x plus something, b1 is equal to a1 this. So we have got those Bellman equations which we can solve. But if I got max of this, max of this, max of this, it cannot be linearly solved. So I have to find maximum of this, maximum of this. So first I have to file q1, q2, q3, and then I will find whichever is maximum, I will select that action. So it is not linearly solvable. Okay.
Yes, sir.
Okay, this is one example. Now DP they have given, so DP dynamic programming guaranteed to converge. What we do, we keep on copies of these value function at every step, and in the next step we use it to update it. So we are keeping for in a synchronous one, we keep two values of value functions. But second one is the asynchronous, which is also known as in place, which they had demonstrated during that demo. So in that we keep only one value function and we use it inside the loop. So it happens in the asynchronous. Now we come to policy evaluation. So now we come to the policy iteration, for example. So in the policy evaluation, what happens? So this is my V pi. Now, if I'm given a policy, then I can find value functions for all the states as per that policy. I keep on iterating, I keep on iterating, and then if the next value function is not deviating by delta, then I freeze it. So that value function, that step is known as policy evaluation. In the next phase, I do improvement. Now, with respect to those value functions, now I become greedy. And in case of tie, I have to be consistently following only one rule. That if I make a rule that in case of tie, I will move north only. So in all cases, I will move north only. Now, when I do policy improvement by becoming greedy, I will find a new policy. So again, I go back to evaluation. With that respect to that policy, again, I will keep on iterating, find a value function. After finalizing value function, again, I do improvement. So this loops, they keep on going until there is no change in my policy. So once there is no change in policy, the this algorithm converges, and that is the policy iteration. In value iteration, what happens? We are combining these both steps, both evaluation and improvement. We are doing only in one go. One go means that we are finding in first step, we are finding the best action. So we keep on doing finding the best action, best action, best action. And once it converges, then in last we find the policy. So that is the difference between policy iteration and value iteration. Now there are certain points in this that number of Bellman updates will be more in the policy iteration, because in the evaluation phase we are updating those Bellman updates many number of times, whereas in value iteration it will be less. But number of iterations to converge will be more in value iteration. For example, for policy iteration, it might converge after 6 or 7 iterations, but for value iterations, it will take more steps. These are subtle concepts of policy iteration and value iteration. Any discussion on this, Lavlinji?
No.
Okay. Yeah. So that was for policy iteration, policy improvement. So it is not difficult. Okay. So algos are there, examples are there. Now, one point is there. There are a lot of questions, calculations on value iteration. So always remember, in most of the PYQs, they have given the questions. Okay, they have given like this, that you have got a state hot, there is one state cold, In this, I can take action, for example, advertise. One is not advertise. If I advertise, then with 0.2 probability or 0.8 probability getting reward of 5, I come back to hot. If or I go from here 0.2, get the same reward, but I go to C. If I don't advertise, then I come back to same hot 0.5, reward is 1, or I go back to cold 0.5 by getting a reward of 1. So this is for hot. Now for cold, I can take two actions. Again, research. So I do research, and if I do research, I come back to cold by 0.21 reward, or I go back to hot with 0.8, for example, and 1 reward. Second is not research. So I come back to cold with the probability of 0.8, 0 reward. I go back to hot, I get with the 0.2, and reward is 0. So in the value iteration, remember there are some very important things are there when we have to solve a question like this. Most of the questions are like this. So in value iteration, remember initially value of hot and value of cold is 0. This is very, very important to remember. And now in the first iteration, for example, I have to find value function of hot. This will be equal to maximum of, I will say, value hot advertise and value of hot not advertise. Okay. Now, if value of hot advertise is there, then you can say it is when I'm advertising, I'm getting a 0.85 plus 0, because this is the, you can say this is 1, and this VH0, VC0. This is VH0, this becomes 0. This 0.25 plus 0. So this becomes 4 plus 1, 5. Not advertise. Again, if we see this is 0.5, 1 plus 0 plus 0.5, 1 plus 0. So this becomes 1. So your value is 5. So your V1H becomes 5. This is important. Similarly, we can find V of cold for first iteration. Again, we will be using these values only because the updates are synchronous. So this will become max value cold research, value cold not research. So this will become research is equal to research 0.21 plus 0 plus 0.8, 1 plus 0. So this will become 1. Not research, it will become 0.2 into 0 plus 0 plus 0.8, 0 plus 0. So this is 0. So here now for the next state, next iteration, I have got V1 cold is equal to 1. So now V1H is equal to 5, V1 cold is equal to 1. And now for the second iteration, again I will use, but only these values will change. So these zeros which are there, this is. So this is how value iteration is to be calculated. Is that okay? Any question on this? Any discussion on this value iteration? Ravina, is that okay?
Yes, sir.
Yeah. So it is easy. So in many PYQs, there are calculations on this. Okay. Now there are some other questions also. So I will cover certain aspects which are different from the lectures. In the lectures, they have not been given. So I will cover, for example, the for a E greedy. So in the last revision, we had covered this. In E greedy, remember the arm with max reward will be selected with E minus 1 minus E plus
E.
E over K, where K is number of arms. Okay. And other arms will be selected with E over K probability. So this is one part. Okay. Now coming to Monte Carlo. In the Monte Carlo MC, we have got first visit and we have got all visits. Okay. So for example, I will take one example from a PYQ. I think there should be a question on PYQ here. Just we'll see. Okay, it is not there. It must be in some other. Lavlinji, so I will just show you that question also. It was, I think, in the previous question. Okay.
This is a 2025 paper, or which year is it?
This all questions are there. 25, it had
Okay,
two
okay.
PYQs, 24, 23. So I think in February it has got. So one thing is this alpha is equal to 1 by K. In the lecture it was covered 1 by K over plus 1. So this alpha is 1 by K. So that is
So
one.
that's because here it is starting from 0
Zero.
and
Yes,
here
yes.
from 1.
Yeah, but in the standard, if you see the book also, it is there starting from 0. So see, Lavlinji, this was the question. See,
No, in this one you got a solid and blank ones.
yeah,
That's why.
yeah,
Because I'm not seeing them skipping this notation, because otherwise it becomes very ambiguous.
yes, yes,
So with this it is easy, because you know that this is a state and this is an action.
yes, yes. So see, this is the question. For example, first visit and second visit, we'll just solve it. So just to get the hang of it, because we have not seen this kind of question in this.
Of all the of the various kind of problems, numericals and things which are there, which ones are the most complex or the most error prone?
Error prone से क्या Lavlinji are these क्या? So which we solved this na? These ones. So here
Okay.
we can do some
Okay.
silly mistake in calculation.
Yeah. Just putting up a wrong probability or just
Yeah,
putting a wrong value.
yeah,
Okay.
yeah. So otherwise maths is very, very simple. Class 9th, 10th maths is there.
Okay.
So in this we'll solve this question for both, for first visit also, and so we will do this.
On the G space, Rohit and somebody was having discussion that there might be questions coming from the programming assignment as well.
No. In the programming assignment, in the PYQs also, what they have asked here. See, in the programming assignment, what did we learn? So I will just cover. So, for example, in the programming assignment, we did epsilon greedy.
Yeah.
We did softmax, and we did UCB.
Yeah.
We implemented only this. So in the
Yes.
PYQs also on these concept, they have asked some questions. For example, that in E greedy and your epsilon greedy is, for example, 0.1, and there are some arms. So they can ask you that how many times your best that arm was selected. So again, the formula is 1 minus E plus E by K.
Okay.
Okay. Similarly, in one of the question they have asked that your 10,000 is the number of arms, and number of steps is also 10,000. So we had seen during programming assignment that UCB will not work, because UCB, it will require this 10,000 to go through all the arms.
Okay.
So there are conceptual questions. There are nothing
Okay.
like that.
Okay.
Similarly, in softmax, what happens if your tau increases? So
Okay.
when tau increases, it becomes uniform. When tau is small, it can distinguish between the two probabilities which are similar. So those concepts, those kind of questions are there, conceptual kind of thing.
Okay.
So Monte Carlo, what happens in the first visit and second visit? So for example, it is asking first visit MC estimate for V pi S3. So see V pi S3 here in T1, it is here. So and the V pi will become is equal to 6. This is gamma 0.9 into 0 because it is this, so it is 6. Here V pi is here, it will become 8. Here S3 is here, it will become 6. So this will become, MC estimate will become 6 plus 8 plus 6 divided by 3 is equal to around 6.67. The second question they're asking, every visit MC estimate for V pi S1 now. Now in the V pi S1, we have to find for V pi S1. So here in V pi S1, here we have got S1 here and we have got S1 here. So here we found S3 was 6. So this will become 6 plus 6 into 0.9, 6 plus 5.4, this will become 11.4. Now this will become, S2 will become 2 plus 0.9 into 11.4, some value will come. And with respect to that, again, we'll get one S1 value. So for example, just a hypothetical example, we get, for example, 12.5. Again, we calculate S1 for here. So it is 8 here, S3. This will become 3 plus 9.9 into 8, 7.2. 7.2 plus 3 is 10.2. This will become 7 plus 5.4, 0.9. So this will become 12.4. So when we do all visits, we will sum up all of these 4 and divide by 4. So this will become 11.4, 12.5 plus 10.2 plus 12.4 divided by 4. So this is the only calculation which we have to do. This kind of question has come twice, so I just thought I will cover this. Okay. So, and now some other thing, for example, in dynamic programming, we do only bootstrapping. In Monte Carlo, we do only sampling. Whereas temporal difference, we do both. We can do, for example, sampling plus bootstrapping, both. It is a combination. So that is one theoretical part. Okay. With this, Lavlinji, I have finished. If there is any other thing we can discuss, we are open.
No.
Ravina, anything else here?
Sir, now I'm confident that I will pass.
No. You would have passed earlier also. Okay. Things are not so difficult as they sounded, before we took this course. Maybe in coming weeks, things will become difficult. Yeah, thank you, Lavlinji. Thank you, Ravina. I will share this document with all of you. So in this document, okay, I will just share with you the other document which is there. It has got all the PYQ, all the solutions, everything commented out. So it has got everything. I'll share that document.
Yeah. So you have already solved one. You saved a document on the PYQ solution already, right?
Yes. So all the all those 5 PYQs are already there.
Okay. Yeah, I have got that file. I'll go through it.
Yeah. Okay. Thank you, Lavlinji.
Thank you, Lalit.
Thank you.
Thank you.
Thank you. Have a very nice day. Bye bye. Take care.